Imagine looking up at the night sky tonight and noticing something massive is missing. The moon is completely gone. If you realized what just happened, your first instinct might be to brace for the end of the world. You might expect gravity to fail, the ground to stop spinning, or to careen toward the sun. But there is no explosion, no catastrophic collision. The strangest part of the moon's suddenly disappearing is that Earth would initially look almost completely normal. This diagram shows our solar system. Notice that the sun's gravitational grip on our planet is massive, and it doesn't care that the moon is gone. Earth continues right on its steady path. We wouldn't suddenly drift off into deep space or spiral into a fiery demise. And despite what you might have heard, the planet's rotation wouldn't abruptly grind to a halt and send everything flying eastward. The immediate danger lies in the sudden vacuum of lunar gravity and light, triggering a slow, relentless unraveling of the planetary systems we take for granted. Just a few hours after the disappearance, the oceans are the first physical system to feel the loss. This cross-section shows how tides work. Water is pulled outward by the gravity of the sun and moon. When the moon vanishes, tides don't stop entirely because the sun still pulls. But these remaining solar tides are half the size we're used to. Coastlines would experience an immediate drop in water movement. Tidal flats would dry out, and the normal daily churning of coastal sediment would severely weaken. This drop in tidal power interrupts the essential flushing of nutrients into the open ocean. Without the intense daily churn of lunar tides, coastal waters stagnate, and the organisms that evolve to feed and spawn here lose their biological cues. The entire coastal food web, from the smallest plankton to birds and fish, collapses from the bottom up. As days turn into weeks, a new reality sets in when the sun goes down. The night sky is now completely pitch black. Without the ambient glow of moonlight, nocturnal predators like owls and wildcats are suddenly struggling to navigate and hunt. Deep in the ocean, it's a similar story. Many corals and marine species synchronize their massive spawning events to the phases of the moon. Without that light cue, their reproductive cycles fall out of sync. Different species respond to this darkness in different ways, meaning the sudden loss of moonlight completely rewrites the rules of nighttime survival across the globe. Months and years pass, and we begin to see the effects on the mechanics of Earth itself. Right now, the moon's gravity pulls on the oceans, and as Earth spins, this creates friction. It acts as a drag that gradually slows down our planet's rotation over time. But with the moon missing, that friction is gone. So instead of violently stopping as many fear, Earth locks into its current rotational speed, spinning at this exact rate indefinitely. To see the true devastation of the moon's disappearance, we have to look millions of years into the future. The moon has a vital, unseen job. It acts as a massive gravitational anchor, holding Earth steady at a 23.5-degree axial tilt. Without this anchor, the gravitational pulls from the sun and massive planets like Jupiter take over, causing Earth's axis to wobble erratically. This wobble creates extreme climate variations. At severe tilts, the poles could point almost directly at the sun, melting the ice caps and freezing the equator. A world without its moon eventually descends into a cycle of extreme, unavoidable climate chaos, forcing life to adapt to a planet that no longer has a steady seasonal rhythm. The consequences unfold in distinct layers. Dark nights lead to weakened tides, which cause ecological disruption, eventually ending in severe planetary instability. If the moon vanished tonight, Earth wouldn't die tomorrow. But over time, we would discover just how much of our world was built around the presence of something we barely notice. The moon has been quietly shaping our oceans, our nights, and our climate stability for billions of years. This is Second Late, where one change can change everything.